To know what temperatures of the Earth were like before thermometers were in common use, we have to use proxies. A proxy is something natural which can be measured, in which responds to changes in temperature. For example, if trees have enough water all the year round, then the main factor affecting their rate of growth is temperature. So this means that the width of tree rings can be used as a guide to past temperatures. In this graph, we're looking at another proxy for temperatures, which is from ice cores. In the Antarctic, ice can be thousands of meters deep and record temperature for hundreds of thousands of years. In this case, we're looking at data from the Vostok ice core. The dark blue line shows the temperature in degrees Celsius expressed as the difference from the present. The red line shows carbon dioxide in parts per million. The horizontal axis shows time before the present, and as you can see, the graph goes back for more than 420,000 years. As you can see, temperatures and CO2 rise almost simultaneously. What you can't see from the scale of this graph, but which is known from more detailed analysis, is in fact that the temperature rises first and is followed by the CO2 some hundreds of years later. You can see the lag between temperature and CO2 more clearly when you look at falling temperatures. Here you can see that the temperature has fallen quite rapidly and the CO2 has taken some time to catch up. You can see the same effect here. Temperature has dropped quite rapidly, but it's only thousands of years later that CO2 has dropped to the equivalent level. What this suggests is that it is temperature which is driving the changes in carbon dioxide, although the carbon dioxide might act as an amplifier and increase the amount by which the temperature changes. The variation in temperature estimated from ice cores is actually likely to be less than occurred in reality. Firstly, the age of the ice and the age of the gas trapped in a particular layer are not the same. As the ice settles, gases tend to rise. So, particularly for some of the early records, what you're actually looking at is the average content over a period of hundreds or even thousands of years. Secondly, it's an inescapable statistical fact that when one data series is used to estimate another, the estimated data will have less variance than the original. What this means is that it's not completely valid to compare temperatures in Earth over a couple of decades with temperatures as measured by ice cores hundreds of thousands of years ago, and statements to the effect that the temperature now is higher than any temperature in the past 500,000 years have to be treated with some degree of suspicion.